Welcome to The White Space, the podcast where we talk about data centers in a simple and practical way.
Welcome everyone to the Deep Dive. This is the place where we tackle complex topics, pull out the key bits so you can get up to speed fast. And today, well, special. This is actually the 6th episode of the White Space Piso Blanco podcast. We're really excited to be here sharing what we love, learning stuff. Today we're diving deep into something that sounds maybe a bit technical. Fire protection and suppression in enterprise data centers. It sounds straightforward, maybe, but it's actually super complex and honestly fundamental to, well, everything digital now.
It really is. You know, these data centers, they aren't just buildings with servers. They are literally the engine room of our digital lives.
Right.
Every click, every stream, every bit of cloud storage, it all goes through these places. So when one goes down, especially because of a fire, oh boy, the impact is huge, immediate.
Yeah, you can feel it ripple out.
Absolutely. Finance, communications, everything.
Before we jump in, a massive thank you is needed for our sponsors, Series Tech and Noxtel. They really help make these deep dives happen.
Are you here?
You can find all the important links for them right there in the description for this deep dive. Okay, so let's unpack this, our plan today. First, figure out what actually causes fires in these places. Seems basic, but maybe not.
Good starting point.
Then we'll get into the systems, the layers of protection. Look at some, well, frankly, scary real-world examples.
Yeah, those really drive the point home.
And then talk about detection, like VSD, what's that all about? And testing, very important. And finally, maintenance. Can't forget that.
Never.
So let's kick things off. What are the main reasons a fire might actually start in an enterprise data center?
Right. It's the perfect place to begin because, understanding the why is key to prevention. And while statistically, big fires are pretty rare.
Hey.
The Uptime Institute says less than half an incident per year globally, which sounds low.
It does sound low.
But when they do happen, the impact is just massive and they're unpredictable. So the main causes usually fall into, let's say, 2 big buckets. First, electrical issues. No surprise there, maybe.
Right. Lots of power.
Exactly. Think overheated servers, they generate a lot of heat. Overheating power distribution units, shorts and electrical panels, even failures in those surge suppressors. The things meant to protect against power problems.
Huh. The protector becomes the problem.
Sometimes, yeah. And something interesting, the IT load in a data center, it fluctuates, right? Power demand goes up and down.
Sure.
That can actually cause electrical wires to physically expand and contract. Over time, connections can loosen up.
I see.
And a loose connection means resistance, which means heat, potentially a fire.
Wow, okay. That's subtle. What's the second bucket?
The second one is maybe more surprising because it seems so simple. Flammable materials.
Like what? Paper.
Exactly. Cardboard boxes from new equipment, plastic wrapping, pallets sometimes. Stuff that absolutely should not be stored in the actual data hall, the white space.
Right. That's the core principle of the White Space Piso Blanco podcast. Keep that area clean.
Precisely. Because obviously it's fuel for a fire. But also, these materials shed particles, dust, contaminants that are terrible for the sensitive IT gear and can clog up cooling systems.
So it's a double whammy. Fire risk and operational risk.
You got it.
It really highlights that mitigation, just stopping it before it starts. It's not just step one. It's probably the cheapest step too, isn't it?
Absolutely. Way cheaper than dealing with the aftermath.
So things like doing regular infrared scans on electrical panels to spot those hot, loose connections before they arc, that seems like a no-brainer.
It should be standard practice, definitely. At least yearly. It catches so many potential issues.
It makes you wonder, though. These causes, they sound quite fundamental. A loose wire, a forgotten box. Does that mean maybe some organizations focus too much on the fancy suppression tech and kind of underinvest in just basic housekeeping and preventative checks?
That's a really sharp observation. And unfortunately, yes, sometimes the basics, the operational discipline get overlooked. It's easier to buy a new system than to enforce strict protocols day in, day out.
Right.
But that discipline is the foundation. And it leads us right into the next point. Good fire protection isn't just one thing. It's not just sprinklers or gas.
Okay.
It's a multi-layered approach, a whole strategy. We usually break it down into 4 key elements. Mitigation, which we just talked about, preventing the fire.
Got it. Prevention first.
Then detection, seeing the smoke or heat early.
Yeah.
Then suppression, actually putting the fire out or controlling it.
Okay, detection, suppression.
And finally, recovery, having a plan to get back up and running after an incident.
So mitigation stops at starting. Detection is the early warning system, the smoke alarm on steroids, kind of?
Exactly. It's the crucial first alert that something's wrong.
Yeah.
It needs to be fast and reliable.
And suppression is the active part, the fire extinguisher or the gas system kicking in.
Precisely. That's the active intervention to stop the fire spreading.
And recovery. That's planning for the worst case scenario, right?
Yeah.
How do you fix the building, restore the data, get services back online? What are the biggest hurdles there after a fire?
Oh, recovery is incredibly complex. It's not just sweeping up ash. It's dealing with water damage from sprinklers or residue from gas systems. It's validating data integrity.
Right.
Reestablishing network connections, dealing with insurance, maybe even relocating temporarily. It's a massive undertaking.
So this whole multi-layered thing, the strategy, it applies everywhere in the data center.
Yes, absolutely.
Mm-hmm.
Think about it at the building level, the whole facility, then at the room level, specific data halls or power rooms, and sometimes even down to the individual server rack level with specialized in-rack systems.
Wow.
That comprehensive layered approach is just critical for places like enterprise data centers. It's something we often emphasize on the Whitespace Piso Blanco podcast, Think Layers.
Layers make sense. So you said fires are rare, but the impact is huge. Can you give us a sense of the cost, both in money and disruption, maybe some real-world cases?
Sure. The numbers are pretty eye-watering. A survey back in 2013, so likely higher now, put the average cost of a single data center downtime incident at nearly $700,000.
Wow. For one incident.
Yep. And for an unplanned outage, the average cost was pegged at around $9,000 per minute.
Per minute. Okay, that adds up incredibly fast.
It really does. And we've seen this play out. Think about UC Berkeley back in September 2015. An overheated server knocked out their main website and campus Wi-Fi for over 12 hours.
Just one server causing that much trouble.
Yep. Or Colt Technology in Milan, July 2015. Overheating power gear caused a fire. 9-hour outage affecting financial firms across Europe.
Financial services, that must have been chaos.
Big impact. Then there was British Telecom in Belfast, June 2015. Fire messed with their power supply, knocked out internet for government, businesses, homes for about a day.
A whole day, jeez.
Or Louisiana's Office of Motor Vehicles, May 2015. An electrical short in a state police data center shut down DMV operations across the state for nearly 24 hours. Imagine trying to get your license renewed that day.
Nightmare.
An Iowa State main data center, February 2014. A failed surge suppressor. Didn't cause huge flames, but enough heat and smoke to trigger the suppression system.
Ah, so the suppression itself caused downtime.
Exactly. Led to a 16-hour blackout affecting state government services. And more recently, people probably remember the OVH cloud fire in Strasbourg, March 2021. That was huge. Destroyed an entire building. Massive disruptions.
I remember that one, yeah.
And there have been others. Incidents affecting Google, KakaoTalk in South Korea. They'll all show the same thing. Even a relatively small fire, or even just the activation of suppression, can have enormous financial and operational consequences that ripple far beyond the data center walls.
These examples really hammer it home. It's not just about the hardware cost. It's the lost business, the service disruption. What about the less obvious costs, like critical public services being hit, or maybe even just the loss of trust?
That's a huge factor, too. If government services go offline, or a major platform people rely on disappears, even temporarily, it erodes public confidence. It highlights our dependency, maybe our vulnerability.
Very true. Okay, so early detection is clearly vital. Let's get into the tech a bit more. What's the real difference between a sort of standard smoke detector you might have at home and these specialized systems like VECA you hear about in data centers?
Great question. It's a fundamental difference in how they work, especially relevant for data centers with their high airflow and sensitive gear. So standard spot detectors, the little discs on the ceiling, they're mostly passive.
Okay.
They wait for smoke particles to drift into their detection chamber. There are a few main types, photoelectric or optical ones. See the smoke particles scattering a light beam. They're good for smoldering fires like burning plastic or wiring that make a lot of smoke early on.
Right, slow burners.
Then you have ionization detectors. They use a tiny radioactive source to create an electrical current in the air inside. Smoke particles disrupt that current. They tend to be better for faster flaming fires that might produce less visible smoke initially.
Okay, photoelectric and ionization. Got it.
And now, many are multi-sensor or multi-criteria. They combine different sensors, maybe optical, ionization, heat, even carbon monoxide, and use algorithms to figure out if it's really a fire.
Smarter detectors.
Yeah, much better at avoiding false alarms while still being sensitive. They can pick up things like rapid temperature rises or specific gases before you even see smoke.
Interesting. Are there other types too?
Definitely. Heat detectors are crucial. They react purely to temperature, either hitting a fixed point or rising very quickly. They're often used to trigger suppression systems directly. Flame detectors use optical sensors to look for the specific light wavelengths from flames, good for places where flames might appear instantly, or high airflow could disperse smoke too quickly for other types.
Okay.
And a newer, important category is lithium-ion battery anomaly detection. With more battery backup systems in data centers, this is critical. These systems look for external stress, but more importantly, they detect specific gases, volatile organic compounds, hydrogen that batteries release before they go into thermal runaway.
Ah, so it's detecting the warning signs before the battery catches fire.
Exactly. Stage 2 thermal runaway is where it gets really dangerous, really fast. Detecting those off gases is key.
Okay, that covers the standard or maybe slightly more advanced spot detectors. But then there's VESDA, Very Early Smoke Detection Apparatus. That name itself sounds significant. Is it really a game changer? And, implementing something that sounds so advanced in a live data center, is that disruptive? Is it plug and play?
Well, it's definitely not plug and play. It requires careful design and installation. But yes, for enterprise data centers, it often is a game changer. The core difference, as I mentioned, is active versus passive.
Right, VESDA sucks the air in.
Exactly. VESDA, or aspirating smoke detection ASD systems generally, use a network of pipes running through the protected area. Fans continuously aspirate, or suck, air samples through tiny holes in these pipes, bringing the air back to a central, highly sensitive detection unit.
So it's constantly tasting the air from all over the room.
Precisely. And this active sampling gives it huge advantages in a data center environment. First, ultra-sensitive detection. These systems can detect smoke particles at levels thousands of times lower than standard detectors. We're talking 0.002% obscuration per meter.
That's incredibly sensitive.
It means detecting a fire in its very, very earliest stage, often before any visible smoke or heat. The real power of VSD isn't just sensitivity, it's that it shifts the paradigm. It's less about detecting a fire and more about preventing one from truly taking hold. Catching those microscopic signs lets you intervene when it's just a potential issue, maybe an overheating component, saving potentially millions before a flame even ignites.
So you can investigate before it becomes an actual fire.
That's the goal. Also, data centers have high airflow from cooling systems, right? CRAs, key units, fans everywhere.
Sure.
That airflow can dilute smoke, making it harder for passive detectors to see it quickly. VSD overcomes this by actively sampling air from multiple points, including return air grills where smoke might concentrate.
Wow, clever.
It also handles congested spaces better. Maintaining spot detectors buried deep inside server racks is a nightmare. With VSD, the detection unit is accessible, the pipes do the hard work, and it deals with smoke stratification smoke, layering at different heights due to temperature differences by sampling air at multiple levels.
Okay, that makes sense.
Plus, VSDA systems usually have multiple alarm levels, like an alert stage for early investigation, then maybe action or fire stages that trigger more serious responses like suppression release or evacuation. And the pipe network can be designed specifically for the room's layout and airflow patterns.
So it's highly customizable and incredibly early warning.
Exactly. That's why it's so prevalent in high-value, high-risk environments like enterprise data centers.
And who are the big players in this space? You mentioned VSD.
Yeah, VSD is actually a brand name, now owned by Honeywell, though it's often used generically like Kleenex. Castoris originally developed VSD, and they have newer systems like VSDE. There are other ASD manufacturers too, but Honeywell Extralis are probably the best known.
Okay, good to know. So we have these super sensitive detection systems and then the suppression systems they might trigger. What about testing? You mentioned prevention, detection, suppression, recovery. Testing must be huge. What's this hermeticity test I've heard about? Why is that so important? And what happens if a room fails it?
Excellent question. Testing is absolutely crucial. That term hermeticity test is descriptive, but the industry standard term is room integrity test, or RIT. And very importantly, this test applies specifically to gas-based fire suppression systems.
Okay, not for sprinkler systems or detection systems.
Correct. Only for systems that release a gas agent like clean agents, maybe older CO2 systems that need to flood the entire room.
Why is it so vital for those?
Because the whole principle of gas suppression relies on achieving and maintaining a specific concentration of that gas in the room for a minimum period, usually 10 minutes. This is called the hold time.
10 minutes, okay.
That hold time is critical to fully extinguish the fire, cool materials below their reignition temperature, and prevent the fire from flaring up again once the gas starts to dissipate. If the room leaks like a sieve, the gas concentration drops too fast, and the suppression might fail.
Right. The gas just escapes before it can do its job, like filling a leaky bucket, as you said.
Exactly. So the room integrity test measures how leaky the room is.
How do they actually do that?
Well, first, they seal up the room as tightly as possible. Doors closed, ventilation systems temporarily dampered off or sealed. Then they use a calibrated fan unit, usually fitted into a doorway, to pressurize the room slightly and then depressurize it.
Okay. Blow air in, suck air out?
Basically, yes. While doing this, they measure the airflow needed to maintain several specific small pressure differences, usually between 10 and 60 pascals, which is very low pressure across the room's enclosure.
So they're measuring how much air leaks out at different pressures.
Precisely. These measurements allow them to calculate the total leakage area of the room. Software then uses this leakage area, the room volume, and the specific gas agent's properties to predict how long the required extinguishing concentration will be held.
And it needs to hold for that 10 minutes.
Generally, yes. Standards like NFPA 2001 or ISO 14520 require that minimum 10-minute hold time, maintaining a pressure equivalent often cited as 25 pascals up above atmospheric. This test must be done annually. Annually, or anytime significant changes are made to the room, new cable penetrations, modifications to walls, doors, windows, if the room fails the test.
Yeah, what then?
You have to find and seal the leaks. This often needs a specialist. They might use smoke pencils or other methods to pinpoint where air is escaping around door frames, cable holes, ductwork connections, and then seal them properly with fire-rated materials. Then you retest.
It sounds like a critical piece of the puzzle for gas systems. What about testing the detection systems, like the VSDA we talked about?
Oh yeah, they get tested regularly too. It's not just the annual RIT for the room. Detection systems are continuously monitored electronically, of course. But they also need periodic functional tests.
Like blowing smoke at them?
Sometimes literally, yes. Using approved test smoke, or aerosols, to ensure the sensors actually trigger alarms at the right levels. For ASD systems, it involves introducing test smoke at the sampling points on the pipes to check the whole system, including transport time. Plus calibration checks, cleaning sensors to prevent dust buildup, causing false alarms, or reduce sensitivity. It's all part of ensuring the system is ready when needed.
Okay, that makes sense. It leads perfectly into the final piece. Maintenance. It feels like the least glamorous part, maybe, but potentially the most important, even with the best detection and suppression, if they're not maintained.
You've absolutely hit the nail on the head. Maintenance is critical and often underappreciated. The most advanced system in the world is useless if it hasn't been properly looked after.
So what does good maintenance look like in this context?
It covers a few areas. First, regular equipment review. This isn't just the fire systems, but the potential ignition sources too. Periodically inspecting electrical gear, cleaning it, tightening connections, replacing old or dodgy components before they fail and cause a fire. It ties back to that mitigation step. It's a philosophy we really believe in here at the Whitespace Piso Blanco podcast, Proactive Care.
So maintaining the things that might start the fire, not just the things that put it out.
Exactly. Then there are periodic compliance audits, regular safety checks, making sure fire safety rules are being followed, are fire extinguishers accessible and charged, are evacuation routes clear. Critically, are people storing combustible junk where they shouldn't be? These audits keep safety top of mind for the staff.
Right, reinforces the rules.
And that brings up the human element. Personnel training. Everyone working in the data center needs proper training. Fire prevention basics, what to do if there's an alarm, evacuation rights, how to use a fire extinguisher, and which type to use on which fire. Electrical fires need different handling than burning cardboard.
Good point. Can't just grab any extinguisher.
Definitely not. And finally, arguably, the cornerstone of preparedness, a robust disaster recovery plan, or DRP.
The plan for when things go really wrong.
Yes. It needs to be documented in detail. Everyone who needs to know should know it. And crucially, it needs to be tested. Regular drills, tabletop exercises. Does the plan actually work?
What should be in a good DRP, specifically after a fire?
It needs strategies for everything. Data recovery is paramount. Backups, potentially off-site replication or using remote co-location facilities for redundancy. How to assess damage, who makes decisions, communication plans, how to restore services in order of priority. It's about business continuity. How do you keep the essential functions running or get them back quickly?
It sounds like a massive undertaking just to plan for it.
It is, but it's absolutely essential. So you test the fire plan, the damage control plan, the recovery plan, ideally annually. And one more thing, operators should proactively give their local fire department detailed info Floor plans, location of key equipment, shutdown procedures, what kind of suppression systems are in place, any specific hazards. When firefighters arrive, the more info they have up front, the safer and more effective their response will be.
That makes total sense. Collaboration is key.
It's a truly holistic view. Mitigation, detection, suppression, recovery, maintenance, training, planning, collaboration. All pieces need to be in place.
Wow. Okay, well, that brings us pretty much to the end of this deep dive. We've covered a lot of ground. From what starts, fires, electrical issues, combustibles, to the layers of protection.
Detection, suppression, recovery.
Right. And the importance of advanced detection like VSDA, the critical nature of the room integrity test for gas systems, and finally, the absolute necessity of ongoing maintenance and planning. It's clear that protecting these enterprise data centers is this complex, continuous effort.
It really is. A multi-layered strategy is the only way.
So to wrap up, maybe leave our listeners with something to chew on.
Okay, here's a thought. We've talked about current tech, but the future is already knocking. We're seeing more integration of AI and IoT sensors everywhere, predictive maintenance algorithms, spotting potential failures before they happen.
Interesting.
So the question for you, our listener, is this. How do you see these cutting-edge technologies, AI, IoT, maybe even more advanced, greener suppression agents that are being developed, how will they further revolutionize the way we protect this absolutely vital digital infrastructure in the years to come? What's the next big leap in data center fire safety?
That is a great question to ponder. The future of keeping the cloud, well, not literally cloudy with smoke.
Precisely.
Thank you so much for joining us on this deep dive into fire protection right here on the Whitespace Piso Blanco podcast. And one last huge thank you to our sponsors, Sirius Tech and Noxtel. Seriously, check out their links in the description. Until next time, keep learning, keep asking questions, and keep exploring. We'll catch you on the next deep dive.